Welcome to NASA's L-1 webcast previewing the final space shuttle mission to the Hubble Space Telescope. I'm Damon Talley of NASA's Digital Learning Network here at Kennedy Space Center in Florida. The Hubble Space Telescope has opened our eyes to the universe in stunning and magnificent ways. Hubble has a unique advantage over the observatories built on the highest peaks on Earth. It doesn't have to look through the atmosphere. That means it sees galaxies, planets, and the birth of stars just as they happened with no distortion. Atlantis and its crew of 7 plan to take that view of space and make it even better. Coming up, we'll show you how the STS-125 astronauts are going to upgrade the telescope. Later, we'll examine imagery in art and culture. Plus, Dr. Mario Livio of the Space Telescope Science Institute will answer some questions about Hubble and its impact on science around the world. But first, we begin with correspondent Rebecca Sprague with a closer look at this amazing telescope. Hi, Rebecca.
Hi, Damon. As you mentioned, there certainly is more than meets the eye when it comes to Hubble. We're here at the Hubble exhibit at the Kennedy Space Center Visitor Complex. We thought it would be the best place to talk about NASA's Hubble Space Telescope. The display is a stunning showcase of the telescope's discoveries and accomplishments. Now, almost 20 years after Hubble first began to unlock the secrets of the universe, 7 astronauts are ready again to fly high above Earth and add years to the life of the most successful telescope ever built. After launching from NASA's Kennedy Space Center, Space Shuttle Discovery released Hubble into orbit in 1990. From its perch high above Earth, Hubble can collect light that has not been distorted by the atmosphere. That means clearer images of events that happened billions of years ago, such as the formation of the earliest galaxies. And unlike other observatories in space, Hubble was built to be repaired by astronauts. In fact, much of the work astronauts performed on Hubble would not have been possible if designers had not built the telescope with modules that could be replaced relatively easily by astronauts working in weightlessness and wearing bulky gloves and spacesuits. The concept was put to the test when astronauts first flew to the Hubble Space Telescope in 1993. Essentially adding a set of glasses to the telescope, they cleared up the observatory's blurred vision with a high-tech instrument that compensated for a flawed main mirror. Since then, 3 other crews brought more instruments and upgraded equipment to the telescope. Each mission extended its life or added to its extraordinary vision. Now it's STS-125's turn to upgrade the observatory. As you may recall, Atlantis was ready to fly this mission in October 2008. It was poised on the launch pad when a critical module already in the Hubble gave out. The unit does several important tasks, including storing the data Hubble records and then transmitting it to Earth. When Hubble was switched to a backup control unit in space, engineers on Earth readied a spare unit to replace it. After extensive testing, the unit was shipped to Kennedy recently, where technicians packed it for loading into the shuttle. The astronauts meanwhile adapted their plans and added the control unit to their already crowded to-do list. For a closer look at how the astronauts will make the upgrades, we'll send it back over to you, Damon.
Thanks, Rebecca. It will take 5 spacewalks, each about 6.5 hours long, to install new instruments, guidance equipment, and that control unit during the 11-day flight. This is how the spacewalkers will upgrade Hubble during the mission. It will take about 2 days for Atlantis to catch up to Hubble and capture it using the shuttle's robotic arm. Then, working in teams of 2, one spacewalker will stand on a platform at the end of the robotic arm. He will hold the large instruments while an astronaut inside the shuttle's cabin moves him around the telescope into place. There is little room for error, especially with instruments as delicate as those of the Hubble. That's why the astronauts have practiced the exact procedures precisely since being assigned to the mission 2 years ago. With the new instruments, astronomers expect to see deeper into space than ever before. They expect to look closer at the atmospheres of planets outside our solar system and maybe find more planets like them. And all the maintenance will keep Hubble going strong until at least 2014. Rebecca takes a closer look at what Hubble has given us already.
This is the Hubble Ultra Deep Field, perhaps the most famous photograph the observatory has taken. Astronomers pointed Hubble's powerful lens at an area of seemingly empty space and found thousands and thousands of galaxies, some as they were being formed more than 13 billion years ago. In cosmic terms, it's like a baby picture of space. In early 2008, Hubble recorded the first signs of methane on a planet outside our solar system. Methane plays a vital role in the chemical reactions that lead to the development of life. All those discoveries require a powerful lens and cameras, but they also require a spacecraft that will not move even slightly while floating in the vacuum of space. Here's Damon to show you how it works.
Thanks, Rebecca. Everything from pointing itself at a tiny piece of space to turning its lens away from the blinding light of the sun is controlled by a set of spinning wheels called gyroscopes. With them, Hubble can turn itself in all directions and, just as importantly, hold still. They work on the same principle as a bicycle wheel. At rest, the bicycle wheel is easy to move from side to side, and it will fall over if held up from one side. Spinning the wheel generates rotational inertia, and it becomes difficult to move it from side to side. You can really feel the difference. Amazingly, the wheel stays up when held from one side. This is why you stay upright as long as your bicycle or motorcycle is moving forward. This is also why a spinning top stays up. To demonstrate how Hubble uses the gyroscopic effect to turn itself in space, I'll stand on a reduced friction surface. Now, a much safer way to try this at home is by sitting down on a swivel chair. Hubble uses electric power to spin its gyros and to turn them from side to side. One must apply force to turn a wheel on its side. Newton's third law of motion, action-reaction, kicks in and spins you around. This is how Hubble can turn itself and lock on objects in many different directions using gyroscopes. STS-125 will provide Hubble with 6 brand new gyroscopes. Although Hubble is renowned for numerous firsts, STS-125 will mark several lasts for the telescope and the Space Shuttle program. Right, Rebecca?
That's right. STS-125 marks the last time human eyes are scheduled to see the Hubble directly. It will be the last time hands will touch it before it is released to orbit on its own for several more years. After a distinguished career, it will eventually be decommissioned and remain in orbit high above Earth and out of the way of other spacecraft. Here at Kennedy, this mission marks the last time 2 orbiters are expected to be on the launch pad at the same time. The silhouette of Space Shuttle Endeavour moved toward Launch Pad 39B recently as the sun peered over the Atlantic Ocean. With Atlantis already at Launch Pad 39A, Endeavour completed the unusual scene of 2 space shuttles standing ready for launch. NASA took the extra precaution of preparing 2 shuttles for flight at the same time, since Atlantis will not be able to seek safety at the International Space Station if something goes wrong during the mission. In that unlikely event, Endeavour would be launched on a rescue mission. It's a breathtaking scene with a serious purpose. Damon?
Hubble's reach extends well beyond science and textbooks. Dr. Mario Livio of the Space Telescope Science Institute said that the cultural outreach may turn out to be the Hubble's most significant contribution.
On the cultural arena, Hubble is really quite unique in that Hubble images have crossed the boundary between science and culture and penetrated into areas such as art, literature, and so on. Really, it has become, the symbol of science exploration.
There are scores of instances of Hubble's crossover from science to culture. For example, a picture of one of the stardust stalks of the Eagle Nebula was printed as part of a series of stamps celebrating the telescope's achievements. The influential rock band Pearl Jam used a Hubble photo of a planetary nebula as the album cover for Binaural. The telescope has been mentioned on notably unscientific shows, including Family Guy. And art museums are exhibiting Hubble images with reverence normally associated with Picasso, Monet, or Cézanne. The exhibits hold up the universe not as a set of data points to be analyzed, but as artwork to be appreciated and marveled upon. It's just another way Hubble brought space down to Earth. That's it from here. Back to you, Damon.
Thanks, Rebecca. The final mission to NASA's Hubble Space Telescope may be one of the most exciting that Space Shuttle astronauts have undertaken. You can follow the launch of Atlantis as it happens on NASA TV or at www.nasa.gov/shuttle. A launch blog will be available along with updated photo and video galleries. You can stay up to date throughout the mission at NASA's website. I'll host a live webcast on the Digital Learning Network during the last hour of the countdown. That's our show looking ahead to Atlantis' STS-125 service.